This video is for the homework 6 and also for the question 2. In the question 2, first we know that x and y are independent with exponential density, and we get the equation of x, the density function of x, and also the density function of y. So since they are independent, so we can easily find the joint density is the multiplier of these two density function, and then we let z equals to x add y and omega equals to x divided y. So we can find the z is equal or bigger than the 0, and also the omega is bigger and equal to 0. So we get the relationship between we get the relationship of z and we get the relationship of z and omega between x and y. So we can easily substitute x with omega and z, and also we can substitute y with z and omega, and the x is equal to omega multiply z divide omega add 1, and y is equal to z divide omega add 1. So since that we can get the Jacobian equation, and we need to use the Jacobian, the result of Jacobian to get into our next step. When we get the Jacobian equations, we can use it to present joint density of z and omega. The theory is that the joint density of z and omega is equal to the joint density of xy divided the Jacobian equation. And finally, to calculate this, and also we need to substitute the xy with z and omega, and finally we can get the result. When we get the result, so this is the density function of z and omega. Since we have analyzed the boundary of z and omega, so the joint density function of z and omega have to be two situations. First is that when z bigger and equal to 0, and omega also is bigger to 0, and this density function is what we calculate by the last step by using the Jacobian function by using the Jacobian equations to get the result, and in the other situations, which means that when z less than 0 or omega less than 0, and the result is equal to 0. So finally we can get the joint density of z and omega. That's all.